Okay, let's see if you can do this one here. Suppose you've got a packet of playing cards. If you were to pick out two cards at random, what is the probability that both of these cards are kings? So you've got a king, maybe a queen, a king of hearts, or king of uh, clubs, whatever. There are four kings. What is the probability that both of these cards would be kings? So press pause and think about it. Remember, this is the whole pack here. Four kings here. One, two, three, four. If you were to pick out two cards at random, what is the probability that they will both be kings? So press pause and have a go. Okay, so again, I think you've got to decide if this is a conditional probability or if this is an independent. Well, imagine you picking out, let's say, one card. Let's say you pick out this card. Okay, then the probability of the second event, which is picking out the second card, depends on the first event. So this would be a conditional. It would be a conditional probability. So let's draw a map of all the things that could happen. Let's say you are here. Well, on your first pick, you could get a king or not a king. Okay, so a king or not king. Now the probability of you getting a king would be 4 over 52. Okay, the probability of you not getting a king would be 48 over 52. Now, suppose you just picked out a king. Let's say you just picked out this king, this king here. Okay. Now, the probability of you getting another king would be 3 out of 52. Now, the probability of you not getting a king now would be still 48 cards, 48 that you're not interested in, which are all these here. Okay. Well, anyway, 48 out of 51. Sorry, this should be a 51 here. Hang on. Should be a 51 here. And let's say you started here. You happen to pick out not a king. Well, the probability of you picking a king and a not king, well, king would be 4. Still remains 4 over what? Over 51, and this one would be 47 out of 51. Okay, because well, the 48 here, well, you just picked out a non-king, so the probability of you picking out another non-king would be, well, you can see all the you can see the second event depends on the outcome of the first event. So this will be a conditional probability. So you're interested in both cards being kings, so you're interested in king and king. So this is the only branch that you're interested in. All these all these are bad here. So to answer the question, probability of king and king equals, well, you need this and this. Remember, if there's an and, you times. If there's an or, you add. So here you need this and this. So it's got to be 4 over 52 times 3 over 51. Okay, so this would be 12, and this would be, hang on, 52, 51 times a 2, so 2, 5, 10, so 0 carry the 1, 25, 26, so it will be 2, what number is that? 50, 5, 6, 2. So it would be 12 over 2, 6, 2, 6, 5, 2. So this would be your answer here. You could simplify, but let's just jump to a calculator and convert that to a decimal. So it's just a matter of 12 divided by 2, 6, 5, 2 equals well, it's a really small likelihood. So it's 0.0045. Hang on, 0.0045. So if you look at this here, It's zero. Well, this is it's really hard to get. So it's roughly, well, this is 0% here, so it's really 0.45%. You know 1% is really hard to get if it's 1%. Well, this here is even less than 1%. Okay, so well anyway, so the probability here would be this. Okay, of you getting a king and a king. So it's actually quite hard to do.